There are three different equations of planes that we're going to be using this semester. The one we're going to be using at the moment is kind of the strangest one, but it's the easiest one, I think, to find the equation of a plane. The idea is, supposing you just have a plane that's sitting out here like this. And what we want to do is pick a point, and we usually call that x naught, y naught, z naught. And what we want is a vector that's sticking perpendicular out of the plane. Just think of any piece of paper that you can put anywhere in the room. You can always stick something straight out from it. So this is going to be a vector that's actually sticking out perpendicular to the plane. They usually call that a normal vector. Normal just means orthogonal to. The use of that goes actually, I think it might predate Chaucer, which is really kind of interesting. Now the idea is, what are we supposed to do? Well, what we do is we pick any other point on the plane, like this. And the idea of being normal means that the normal vector is going to be perpendicular to any vector I can draw on the plane. So there's a vector that I can draw on the plane. And I just want to write everything out and say, hey, it's perpendicular. Now, this vector right here has components. Now remember, this is a displacement vector. Displacement vectors always start at a specific point, end at a specific point, but we can find the components for it always by taking the end point and subtracting the starting point. So that particular vector is just the vector x minus x naught, y minus y naught, z minus z naught, like that. And what we know is that this normal vector, by definition, is perpendicular to any vector that sits in the plane. So we know right away, because that's normal, is that the dot product of the two is 0. So I'm just going to write down the dot product of the two is 0. So I'm going to write down A and B and C like that, dotted with x minus x naught, y minus y naught, z minus z naught, and we know in advance we're going to get 0. Well, we now know how to take the dot product of two things, so we're just going to do this, and we're going to get our final answer. We're going to get A times x minus x naught plus B times y minus y naught plus C times z minus z naught equals 0. And that's called the point normal form of a plane. But again, how we found it is probably more important than the actual equation itself. But it says that if A, B, C is a normal vector and x naught, y naught, z naught is a point on the plane, then this whole thing inside the red box is an equation of the plane.